Autoboxing is one of those weird patterns in your application. Sometimes it's not really a performance problem, but when it is, wow, does it chew through your memory and performance. My name is Colt McCandless, and thanks to the Android runtime, you can avoid one of the largest causes of autoboxing issues: hash map containers. Now, autoboxing is a process where the runtime automatically converts a primitive type to its corresponding generic object type, but this is bad for two reasons. Firstly is that autoboxing will generate an allocation of an integer object for any type of conversion it uses. And secondly, these generic objects are larger in size than their primitive counterparts, 16 bytes for an integer object rather than 4 for a primitive. Meaning not only are they allocating objects, but those objects are much larger than they need to be. Now, typically this isn't a big problem for your average computation, but where it really gets you is when dealing with generic containers like hashmap. See, when using a primitive types like int, float, and bool, hashmap has to use the object versions. So instead of being able to use a simple 32-bit int, a hashmap is forced to use a generic integer objects, which of course eat up more memory. And you need to be careful here because anytime you fetch a primitive from a generic container, autoboxing happens there as well. Now, memory matters to Android, and to save space, the Android runtime provides a whole family of generic containers built specifically to provide the functionality of a hash map, but allow you to use primitives and avoid autoboxing. Welcome to the SparseArray family. Sparse arrays are basically like array maps, and they reduce the overall memory footprint by using two tightly packed arrays rather than one large one for hashing. But it also comes with some overhead for fetching objects, so they're really only useful for containers with hundreds of objects rather than thousands or millions. The main difference between sparse arrays and array maps is that for sparse arrays, the key object is always a defined primitive type rather than a generic, allowing you to save memory and avoid autoboxing. But in reality, the differences stop there. Like array maps, you can also iterate over sparse arrays using indexing rather than the iterator pattern, which is required by hash maps and is also significantly slower and takes up more memory to do. And also, like array maps, it's not wise to use these optimized sparse array family containers in every single case, but there are some perfect situations which you should consider. Number one, situations where you have a small number of items, in the hundreds, of lots of accesses, or the accesses themselves are infrequent enough that the overhead for a fetch isn't noticed. And number two, situations where we have containers of maps. Often it's a map of a map of a map, where the submaps, as you get farther in that stack, tend to have smaller number of items. And we also end up iterating over those submaps a large number of times. If your use cases don't fall into either of those two buckets, then it might be best to stick with the hashmap class instead of one of these fancy, awesome alternatives. Which highlights a very interesting point. Optimizing performance is a constant trade-off of finding the right container for the right usage pattern, for the right memory cases. As someone said, there's no silver bullet, which is why you need to check out the rest of the Android Performance Patterns content to get more information about these types of trade-offs. And don't forget to join our Google Plus community as well to hear war stories from other developers. So keep calm, profile your code, and always remember, perf matters.